Hi, my name is Catherine Unger, and I'll be talking about the results of a camera trap survey I did that investigated how wildlife uses trails. Just a heads up before I start my presentation, all of the pictures on the slides are camera trap photos that were taken during my study. So the research question that I was interested in further exploring is, how does wildlife use trails? Research has shown that trails might serve as convenient travel routes for animals to help them minimize their net energy gain when they're foraging for food resources. However, it's also been shown that the human disturbance that occurs on trails might have a deterring effect on wildlife and scare animals away. The predator shelter hypothesis is the theory that suggests that predators are more sensitive to human activity than prey. And so the idea behind this is that predators might be more likely to be found off trail because they're avoiding human disturbance, and that this can encourage prey species to seek refuge on trails to avoid being near the predators. To test out my objective of seeing how wildlife use trails, I compared trap success and species diversity between camera traps that were placed at sampling sites on and off trails. I also looked more closely at how deer in particular respond to the presence of trails by constructing occupancy models that had trail as a covariate. And then to test out the predator shelter hypothesis, I compared trap success for both predators and prey by trail, and I used occupancy models for predators that also had trail as a covariate. This study was carried out at the Mattaponi Wildlife Management Area in Woodford, Virginia, which is shown here on the satellite map. We deployed 8 unbaited camera traps there in 4 pairs, with one camera trap placed directly on the trail corridor, which is shown on the map by the red pins, and then another camera trap placed about 200 meters off the trail, which is shown by the blue pins. The study was carried out in collaboration with Snapshot USA, which is a Smithsonian project that documents mammal diversity across the United States, and so we followed their protocols for the methodology. For data analysis, I used t-test to compare trap success by trail, a Shannon diversity index to compare species diversity by trail, and then I used the program presence to construct my occupancy models. Overall, there were 472 camera trap events taken during this study, and a trap event is defined as one animal being captured within a 30-minute time period in order to avoid observing the same individual more than once. We found 11 different species, including 8 mammals and 3 birds, and these organisms are all shown on the x-axis of the graph. The y-axis shows the trap success for each animal, which is the number of trap events that it was captured in per 100 trap nights. And so the graph shows that deer and squirrels had the highest trap success, while the bobcat, red fox, and wood duck were each only captured during 1 trap event, and so they had really low trap success. This graph shows that on average, trap success tended to be higher off trail than on trail. However, there's a really large overlap between the error bars, and the t-test results show that trap success is not different by trail. This graph shows the Shannon Diversity Index results, and it also shows that there is no significant difference in species diversity by trail. This table shows the occupancy model results for white-tailed deer, with psi representing occupancy probability and p representing detection probability. The topmost supported model is shown in the top row of the table, and it's the one where occupancy was constant and detection probability varied by trail. And then the model output shown up here estimate detection probability to be higher off trail than on trail for deer. The second top model, which was also had a delta AIC value under 2, was the null model. For the predator-prey objective, I defined predators to be bobcats, barred owls, coyotes, and red foxes, and I categorized all the other organisms to be prey species. The graph on the left shows the same pattern of predator trap success tending to be higher off-trail than on-trail on average, but there was still no difference by t-test. However, there were only 6 predator trap events during this study, which is a super low sample size, and so this might not have been powerful enough to discern if there was actually a pattern. And then the graph here on the right shows that there was also no difference in trap success for prey. This table shows the occupancy model results for predators, and the top model was the null model, which is shown in the top row. And then the second most supported model was the one where occupancy was constant and detection probability varied by trail. And then the model outputs estimate predator detection probability to be slightly higher off trail than on trail. So overall, wildlife did not appear to be influenced by trails because there was no significant difference in trap success or species diversity by trail. The occupancy model results found deer detection probability to be higher off trail and occupancy to be constant. There was a deer captured at every camera trap at least once during the study, so it's not really surprising that their occupancy would be constant across all sampling sites, though. And then predator detection probability was also found to be higher off trail, which is interesting because it contradicts the t-test results that did not find a difference in trap success by trail. This shows that there might be some partial support for the predator shelter hypothesis, and it's definitely something that should be investigated further in a study that has a higher sample size for predators. Thank you for watching, and thank you to these people listed on the slide for supporting my research.